All right. Solving by graphing. So we have already talked about how like solutions, x-intercepts, roots are your all the same. So when I solve by graphing, I'm looking for my x-intercepts. So I can factor this and I can see, so what multiplies to be 8 and adds to be 6 is x plus 2 and x plus 4. So what value can I put in here? Notice this equals 0. That's going to make this equal 0. Well, if I put a negative 2 right here, that makes this piece 0. 0 times anything is 0. So negative 2, if I put a negative 4 in here, 0, that makes this piece 0. So x plus 2 times 0 is 0. So I already know the answer by factoring. But it's going to ask you to do it by solving, and so you need to know how to do that. But you can check it because you already know the answer. So I have this table here. I know my y-intercept is at 8. I'm going to zoom in because this graph is pretty tiny. Okay, so there's my y-intercept, so I have this point here. I'm going to do my vertex, so negative b over 2 times a would give me a negative 3. If I plug that in, that would give me 9 minus 18 is negative 9, plus 8 is negative 1. So my vertex is at negative 3, negative 1. So now I have my vertex. I'm going to pick a point to the left of it, plug that in, negative 4 squared. Okay, I get 16 minus 24 plus 8, which gives me 0. Well, look, there's my root that I already knew. Okay, I'm going to pick a point to the right. Negative 2 squared plus 6 times negative 2 plus 8 gives me 4 minus 12 plus 8, which is 0, which I already knew that from this guy. Okay, my axis of symmetry is right along here. So since my y-intercept is 3 to the right, I know I have this point 3 to the left, which is at negative 6, 8. And now I can make my parabola. And I did some extra work in here because all I'm doing is trying to solve by graphing, and which means I'm looking for the x-intercepts, which I have right here. Okay. So if I look at this one, I have a y-intercept at negative 3. My axis of symmetry would be negative b over 2 times a. Plug that in. So that would be 1 minus 2 minus 3. Okay, so I'm going to pick a point to the left of my vertex. So I'm going to go negative 2. Plug that in. So 4 minus 4 minus 3, which puts me here. Does that make sense? Yeah, because my vertex is a mirror, and so I have one, that green point is 1 to the right, so I should have this point at 1 to the left. Okay, but that didn't help me get my roots, so I got to pick another point, so I'm going to pick 1, plug that in. So 1 squared is 1, plus 2 is 3, minus 3 is 0. Okay, so there's a root. And then I'll pick, let's see, negative 1, negative 2, negative 3. Negative 3 squared plus 2 times negative 3 minus 3. 9 minus 6 minus 3 gives me 0. So those are my roots, my solutions, my x-intercepts. If I look at this, what multiplies to be negative 3 and adds to be 2? X plus 3, x minus 1. So should I have a root at negative 3 and 1? Yeah, which I do. When we graph a parabola, we have 3 types of solutions. We can have a graph that does not cross the x-axis, so this has 0 or no real roots. Notice I use the word real because here in a little bit we're going to get into imaginary numbers. I can have my x-intercept or root right on the x-axis. This would be 1 real root. We also call this a double root. Or our parabola can do like it's done and it can cross 2 times. So we would have 2 real roots. Okay, so now look at number 3. It says solve by graphing, but it says if you can't find the exact roots, state which integers the roots are located between. So up here, we found really nice answers that cross beautifully right here and right here. My guess, based on the directions, is that this one's not going to be so nice. So first thing, does anything multiply to be -1 and add to be 4? Or I guess we could multiply by that negative. So does anything multiply to be 1 and add to be 4? No, so I can't factor this. So I'm going to have to graph it. I have a y-intercept at -1. Okay, my vertex is -b over 2 times a. So that's going to give me a 2. Plugging this 2 in. Okay, 2 squared is 4, but that negative makes it a -4 plus 8 minus 1 gives me 4 minus 1, which is 3. Whoops, I don't know why I went down. That was silly. Okay. And then, let's see. Did I do that right? -b. Okay, yeah, we're good. Sorry. Okay. And then since I have this point over here, 2 to the left, I know I have this one over here, 2 to the right. Okay, I'm going to pick the 1 and plug it in just to give me another point next to my vertex there. So -1 squared plus 4 times 1 minus 1 is -1 plus 4 is 3 minus 1 is 2. And then I'm going to pick 3. So plug in 3. Gives me -9 plus 12 minus 1, which also gives me a 2, which I knew that because of my vertex, and I don't have any kind of stretch, so I knew it would be 1 away. Okay, so what are the solutions? What is it asking us to find? That was a beautiful straight line. So it crosses the x-axis, but do you see how it crosses in the middle here? So it's like right here and right here. It's not at a nice intersection. So if I look at this first one, this is between 0 and 1. And then between 3 and 4. So my roots, my solutions are between 0 and 1, 3 and 4. All right. So why don't you pause the video and try this one. Okay, this is going to be a question that comes up in the future, but I am going to do it. But pause the video and see what you can do. So I have a y-intercept at 2. And I'm going to do my vertex. So -b over 2 times a. So plug that in. I get 4 minus 8, -4. So -2. Because I have this point 2 to the left, I know I have this point 2 to the right. Then I'm going to pick 1. 1 squared minus 4 plus 2 is -3, -1. Then I'm going to pick 3. 9 minus 12 plus 2 gives me -1. Whoops. zooming in so that I can draw a better picture. So when you're doing this, I'm going to look at your graph because we're human. I can zoom in on my iPad so I can see where it crosses nicely. You can't do that on your paper. So I'm going to look at your graph and see did they list the integers according to their graph, and is their graph accurate? So I'll have a little bit of leeway on this. Obviously, I want it to be as accurate as possible, but if you have it slightly off, but it matches your paper, then you'll be good. So I don't have my calculator here, so I'm going to skip this one, and this is one we can do together in class, because I don't have a way to show you a graphing calculator on this. But on a word problem, you would just use your calculator anyways to kind of see. If I wanted to look at this, it says the highest bridge in the United States is the Royal Gorge Bridge in Colorado. The deck of the bridge is 1,053 feet above the river. Suppose a marble is dropped over the railing from a height of 3 feet above the bridge deck. How long will it take the marble to reach the surface? So, what are you trying to find? So you are standing on this bridge up here, and you're dropping a marble down into the water down below. I want to know, when's it going to hit? Well, what is that in terms of a graph? That's a root. So I would plug in to my calculator negative 16x squared plus 1056, and then I would find my roots. I'm going to have another root over here, but I don't care about negative time. And so I would plug this into my calculator, find this root, and get the time that way. But we'll do that together in class. So let me know if you have questions. Thanks for watching.